Let's go ahead and continue our discussion on discrete probability distributions. So one thing to keep in mind is that a probability distribution is two properties, right? When we look at, and here's an example here in this table here, when we look at the possible outcomes, right, these discrete values, 3, 4, 5, 6, in this case, the number of years it takes to earn a bachelor's degree, and then the frequencies, right, the probabilities, the sum of those probabilities must add up to 1, right? These are specific properties to a probability distribution. Now, when we analyze a probability distribution, we sometimes call that a PDF, right? Not a document, but a probability distribution function. We can then answer some questions. Now notice the probabilities are given to us, or somehow we've collected that and obtained that through data collection. And these frequencies, these values here, we can analyze through as a probability or a percentage technically, right? In the past, 5% of people get bachelor's degrees in 3 years. So, but we can, again, analyze that through the lens of probabilities and random variables. If you randomly select someone, right, what's the probability they earn a bachelor's degrees in more than 4 years, right? What's the probability? And so you can look, we would look at 5, 6, and 7, and that's this case here, part C. You would add up those probabilities, and so 55% chance. And again, that's given off of long run frequencies, right, of this variable, which is the number of years it takes to get a bachelor's degree. And so in this case here, I want to look at these questions real quick. One is, what is the variable, right? The number of years. What does it mean that the values 0, 1, and 2 are not included here? Again, that means that they're just not possible outcomes in this data set that we had. 0, 1, or 2. No one graduated in those years, so it's not part of our distribution. So 0 probability. Now, an important concept here that leads us to expected value, right? The expected value of a discrete random variable. Again, it's this idea of, in the long run, right? On average, what are the outcomes we would expect to see on average? It must call the expected value of a discrete random variable, right? And so there is a complex formula. There's the mu symbol that we learned in the past. E of x stands for expected value of the random variable. And there's a calculation here. It's very simple to calculate. Get a calculator out, and what you do is you multiply your x value times your probability, and you obtain your expected value. So looking at these couple of examples here, you have a men's soccer team, how many goals they score on, and the probability they score those many, sorry, not the number of goals, the probability that they play 0 days in a week is 20%, they play 1 day in a week is 50%, and they play 2 games a week is 30%. So on average, right, how many games would you expect them to play in a week? And you just take the expected value, which is, again, just an average. That's it. And we use the word expected value because it's related to a random variable. So this expectation, what do we expect, right? The likelihood. What's the probability, right? What's the likelihood of something happening? And then how often can we expect to see that to happen? Again, no one's going to play 1.1 days. This is an average, but we get a sense it's probably closer to 1 day than 2 days when we look at that. And this last expected, before we look at harder ones, example 3, here's again a table of values, right? The discrete random variable values. In this case, it's the number of cars sold during the first hour of business on Friday. How often, right, those values occurred in the long run over 50 Fridays. You get this distribution here, and then we can calculate the expected value. We would expect about 1.1 cars to be sold, just a coincidence, it's the same value. 1.1 cars to be sold on Friday morning, right? And of course, you can't sell 1.1, but again, this on average. So to me, you would say that more likely 1 car is sold, right? Again, although you can get 2 and 3, in general, it's 1.1 cars. It gives you a sense of the expected value, how many you expect to sell on a Friday morning.